Microscope was initially placed in air, refractive index 1. It is then immersed in oil, refractive index 2. For a light whose wavelength in air is lambda, calculate the change of microscope's resolving power due to oil and choose the correct option. Resolving power will be 1 by 4 in the oil than it was in the air. Resolving power will be twice in the oil than it was in the air. Resolving power will be 4 times in the oil than it was in the air. And resolving power will be 1 by 2 in the oil than it was in the air. We know the formula for resolving power, Rp air. In air it will be is equal to 2 sine theta by 1.22 lambda air, or simply lambda itself since there is no medium. Now resolving power in oil will be 2 sine theta by 1.22 into lambda wavelength in oil. Now lambda oil we can write it as mu by lambda. We can write it as lambda air by mu. And when a medium extra comes, lambda of oil, when medium extra comes, then we can divide that refractive index with the initial wavelength to get the wavelength after putting the medium. So we can write 2 sine theta into mu oil itself 1.22 into initial wavelength. Now with this we can understand that this is the same as Rp air. So we can write Rp oil is equal to Rp air, resolving power in air, into mu. Mu of oil is given as 2. So we have Rp air into 2. Now resolving power in oil will be 2 times than that of air. So that is our option B. Resolving power will be twice in the oil than it was in the air.